I'm Anil Kumar, and in this video we'll understand few fundamental concepts. If derivative of a function is continuous, use L'Hospital's rule to show that limit x approaches, it should be h approaches 0 for f of x plus h minus f of x minus h over 2h is equals to f dash x. That is to say that this limit is equal to the derivative of this function at x. So that's the question for you. You can pause the video, answer the question. Well, to apply L'Hospital's rule, we should see whether we have indeterminate form or not. So if I substitute h equals to 0 in this particular case, what do I get? I get f of x. I get f of x minus f of x divided by 2 times 0, and that is 0 over 0, right? So that is 0 over 0. Since we have indeterminate form, we can apply L'Hospital's rule, right? And therefore, I could write this expression as limit h approaches 0, and derivative of this will be f prime x plus h times 1, of course, and minus f prime x minus h, but this will be times minus 1, right? Minus 1. We are differentiating with respect to h. Here it has to be multiplied by 1. I didn't write it. Divided by derivative of h is 1, so we get 2. So this is what we get, right? So we get f prime x plus h minus f prime x minus h times minus 1 divided by 2. Now if I substitute h equals to 0 now, then I get f prime x minus, I'm substituting h equals to 0, that minus 1 will make this as plus, right? So we get f prime x minus f prime x minus h, and that minus makes it plus, right? This minus 1 makes this plus, divided by 2. And this is equals to 2 times f prime x divided by 2, or it is equals to f prime x. That is the derivative of the function, right? So from here we have got the fundamental equation, that is difference of quotient is the derivative. Now it has huge significance. Can you kind of show this on a graph? What does it represent? Well, here is the graph. So if we have x and y axis, where x represents the independent variable and y the dependent variable, let me just sketch a curve here, and let's say the curve is kind of like this. Let's just sketch a curve like this. Okay. Now when I say x plus h, so we may have a point here which is x plus a minus h, right? So let's say x minus h is this point, and let's say x is somewhere here. Okay, so x plus h will be same distance on the right side of x, so let's say this place will be x plus h. So when I'm saying that the distance between these two will be 2h, so if I join or make a triangle kind of like this, right? So this distance from x minus h to x plus h will be 2h, right? And this height will be, the value of this point is f of x minus h, and the y value of this will be f of x plus h, right? And therefore this difference is going to be f of x plus h minus f of x minus h, right? So this is the rise kind of thing. And so the ratio of x plus h minus f of x minus h divided by 2h, which is this length, gives you the slope, right? So which gives you the slope kind of like this, going through the middle. And that slope gives you the average rate of change, right? So in a way, what we have done here is that we have related average rate of change with instantaneous rate of change, which is in our case f dash x, right? The average is this ratio, correct? This is difference quotient x plus h minus f of x minus h divided by 2h, right? Now when this h becomes very, very small, so as h approaches 0, that means this gap closes up, right? As this gap closes up, then this will be tangent at the given point, right? So it will be kind of very, very close. So this will be tangent at this point, a equals to x, right? Do you understand? At this point. So that is what it means. So it gives you a way of relating average rate of change with instantaneous rate of change. So it has huge significance. I'm Anil Kumar, and I hope you appreciate it. You can always subscribe and share my videos. Thank you and all the best.